Today we are going to do something not as complicated, but it gets complicated when we start multiplying things out, so it can be kind of tedious. It's the fundamental theorem of algebra. What that is that a polynomial function of degree n, so if it has a fourth degree, it has exactly n zeros, so 4 zeros. Included repeated zeros, which were the multiplicities, and that's in a complex system. But if there's conjugates, like the conjugate root theorem is saying that if we have a complex number, so a complex number was this guy. If we have a complex number as a zero, its conjugate is also a complex number. So when we did operations of complex numbers, we had to multiply the denominator by its conjugate to get a real number, right? And then this one is like a radical solution. It's still a real number, but any radical that has, a positive root has to have its opposite root as a zero as well. So square roots, any even roots really should have both a positive and negative solutions of that root. And typically they won't be nice square roots, but because that would just give us a nice whole or like a nice integer, which are kind of easy, the ones that we've been doing before. So let's get right into it. There's only 5 questions today, but again, it's probably because they're a little bit more tedious. A polynomial of degree 5, whose coefficients are real numbers, has the zeros -2, -3i, and 2 plus 4i. Find the remaining 2, 0, and write as factors. So, as I just mentioned, the complex zeros, if these are zeros, their conjugates must also be zeros. So not only -3i is a zero, but +3i is also a zero. And not only is 2 plus 4i a zero, but 2 minus 4i is a zero. So when I say write as factors, we did this yesterday or the time before, where we wrote out, basically x minus the factor, right? X minus the 0 to find the factor. So we would have x minus a -2, so that's x plus 2. We would have x minus a -3i, so that's x plus 3i. And then we would have x minus 3i. And then this one becomes a little bit complicated because it's x minus, and then in parentheses, 2 plus 4i, and x minus 2 minus 4i. And that's basically writing out the factors. We could simplify it a little bit further if we wanted to, and distribute this negative to the inside, but none of the questions on the homework are going to ask you to just write out the factors. It's just going to ask you to find the other zeros given some zeros already. But one of the problems down below, we might actually have to FOIL some of these things out, so we'll see how that looks. Okay. Write a polynomial of least degree with real coefficients in standard form that has zeros, -3, 1 with a multiplicity of 2, and -4. So we have zeros here. So I'm just going to write the zeros again. We have zeros of -3, 1 multiplicity of 2, so that says that we have x minus 1, x minus 1 times x minus 1, or x minus 1 squared. And then we have negative 4i, and because it's a complex number, we have to have its conjugate of positive 4i. So when it says write a polynomial of least degree, if we look at how many zeros we have here, this is 1 0. This is 2, 3 zeros because a multiplicity of 2, I didn't write that, 2 there. Multiplicity of 2. So that's really 2 zeros because the 1 repeats. Oh my gosh, sorry. And so we have 1, 2, 3, 4, 5. So our degree of this polynomial will probably be 5. And I know there should be plenty of space on your paper, but sometimes it doesn't show up as nicely, and my writings appears larger. So let's go ahead and set it up in factored form. What would that look like? That x minus 3 is x plus 3. That's one factor. And then we have plus 1, x plus 1, x minus 4i, and x plus 4i. Okay, so if, again, kind of like we did up there, and when we have conjugates, they'll always come out to be in pairs like this. 1 plus, 1 minus. Now, in standard form, that means I have to FOIL all of this stuff out. That's where it gets a little tedious. So I think it's best to start here because we can easily make that into x squared plus 2x plus 1. So again, if I FOIL that out, I shouldn't have to necessarily do x squared plus 1x plus 1x plus 1. You can do that necessarily in your head. So that's going to be one thing. And then I'm going to do these two guys. If you recall, when we multiplied by a conjugate, something happened to the middle numbers. They canceled because they were opposites, right? This technically is x squared minus 4ix plus 4ix minus 4i squared, right? So I would have automatically just didn't even do this, and did x squared minus 4i squared. Because I knew with them being conjugates, the middle two terms would cancel out. And I squared is negative 1. So this really becomes an x squared plus 4. And then I'm just going to drop this x plus 3 here. Now it's probably best to FOIL this guy and this guy because if I were to distribute this stuff into here, I'm still going to have to distribute that stuff into there. So why not just make it simpler on myself and do these two first? So if I FOIL that, that's going to get me x squared plus 4x. So first, outer, inner. That's plus 3x squared. And then the last is plus 12. And I mix this. It should be an x to the third. Okay, so we got that stuff. And now we have this stuff still there. X squared plus 2x plus 1. There's no rhyme or reason why I'm putting brackets and parentheses. I just happened to do that. Oops. So now I'm going to need to distribute this into here, this into here, to everything, and then this into here, into everything. So we can do it one or two ways. Oops, plus. Just gonna keep those lines under there. I'm gonna do this. Well, again, it doesn't really matter the way, but I'm gonna do x squared times everything on the inside of that. So I've shown you before that we can do like x squared times all that stuff, plus 2x times all that stuff, plus 1 times all that stuff, right? And what I mean by all that stuff is all of the green there. The x cubed, dot, 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 x cubed, dot, 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 x cubed, dot, dot, dot. If that's a better way of doing it, I'm just going to go about it as doing x squared times x to the third. That is x to the fifth. So awesome, I already know that my degree is in line with how many zeros I have. Then I'm going to do x squared times 4x. That's positive 4x to the third. X squared times positive 3x squared is positive 3x to the fourth. X squared times 12 is positive 12x squared. All right, now I'm going to do the same thing. I'm already finished with this x squared, but I now need to do it with the 2x. So 2x times x cubed is positive 2x to the fourth. 2x times 4x is positive 4x squared. 2x times positive 3x squared is positive 3x to the third. And then 2x times 12 is positive 24. Oh, I mixed this. This shouldn't be 3. This should be a 6. And that should have been an 8. That's why I miss being in class with y'all, because y'all be correcting me. 6x cubed and then 24 on the end there. 24x. And yes, I gotta go do one more. This positive 2 or positive 1 times all of this, well, that's kind of nice. It's basically just adding on what's in green because it's times 1. Now I must combine like terms. What's really nice is that I already have x to the fifth out in front. Now in standard form, it needs to be in decreasing degree order. So I'm going to need to do the fourths power, So I got this guy and this guy. I'll box the fourth powers in. If you have colors, you can underline them in a different color. So that is positive 5x to the fourth. Now I'm going to do all the cubes. I'm going to circle my cubes. What's really nice is that all these things were positive. So we got 4x cubed. We got a cube here. Oh, and we got a cube here. So I'll circle those. 4x cubed plus 6x cubed is 10x cubed plus 1x cubed is positive 11x cubed. And then I'm going to need to do the squares. So I am going to do a squiggle line under here. 12x squared, 3x squared, so positive 15x squared. Oh, I missed this guy. So not 15x. 12x plus 8x is 20x squared plus 3x squared is 23x squared. Then I'm going to do my x's. So, I don't know, just, I'm not really like another shape, but triangle them. Positive 24x plus 4x is positive 28x. And then I have that constant at the end, which is positive 12. And that would be a polynomial given those degrees. I think I have one question like that on one or two, maybe on the homework tonight. All right, this one's a little bit more complicated because this conjugate or this complex number is a minus bi, right? It's not just a b, right? This one up here in 2, it was just the 4, right? You see it was just the 4i, where this guy right here is 3 minus i. So I'm going to have to do something like this in number 1. But let's start off with these zeros, or what would another 0 be given I have 3 minus I? The conjugate of that must also be a 0. The negative 2 minus 4, negative 2 and 4, so that would be x plus 2 and x minus 4, right? If I made them as factors. And then, this is why I use brackets for this, because I'm going to have x minus parentheses 3 minus I, and then the brackets, and then some more brackets, x minus the 3 plus I. Okay, so that's in factored form. I must now multiply out. So the best thing to do is to FOIL this first, and then I will show you how to simplify these complex numbers to make it look nicer. So let's go ahead and FOIL. That's x squared, and if you need to do it out, minus 4x plus 2x minus 8. So that's x squared minus 2x minus 8. And again, if you just want to go straight from this guy to this guy, I am okay with that. So I'm gonna, yes, we'll just go there. Okay, so how do I go about simplifying this stuff? We're gonna distribute the negative inside, and we'll see something that comes out kind of nice. This is x minus 3 plus I. And then this is x minus 3 minus I. Well, what if I put some parentheses around these guys? That's kind of looks like an a plus bi, doesn't it? And that's a plus bi, where this is the a minus bi. And what do we know about conjugates when we multiply them? The middle terms will cancel out. So there's really no outer and inner term we actually have to do. Okay? So what I mean by that is I can do x minus 3 squared minus I squared. Works out kind of nice, doesn't it? What is I squared? We know that that is, and then I'm going to put this in brackets here. I squared is negative 1. So keep simplifying a little bit further. I'm going to need to FOIL that out. X minus 3 times x minus 3. So that's going to be, I'll keep it in brackets, I'll keep my yellow. So that is x squared minus 6x plus 9, and we know that this becomes a negative 1, so it's a negative times a negative 1, so that's plus 1 right here. I now am pretty, not necessarily easy sailing, so you have some more space to the right that we can go about doing this. Let me just move this. That was x minus 3 times x minus 3. So going further here, I'm going to have x squared minus 2x minus 8 times x squared minus 6x plus 10. And if we go back to the original question, least degree with real coefficients in standard form, we had 1, 2, 3, 4 zeros, 4 roots, right? So I need my degree to be 4. So I'm going to basically take this guy and multiply it to x squared. So that's x to the 4th, and I'm probably going to need some more space, so I'm going to eliminate my x to the 4th, x squared times negative x. That a negative 6x is negative 6x to the 3rd. I now have x squared times positive 10. So this one's a lot easier than the last one. Not as many things. And that is positive 10x squared. I then need to do this negative 2. So I will cross this guy out. I've already done him. I need negative 2x times x squared. That is negative 2x to the 3rd. Negative 2x times negative 6x is positive 12x squared. And then negative 2x times positive 10 is negative 20x. All right, got to keep going. I'm going to go back to the blue here. So I'm done with this negative 2x. I now need to do it negative 8 times x squared. That's negative 8x squared. Negative 8 times negative 6x is positive 24. Oops, positive 48. Positive 48x. And then negative 8 times positive 10, which is negative 80. All right, now I'm ready to combine some like terms. So x to the 4th is pretty much by itself. So I will just use this color for that. Now the cubes. So I have negative 6x cubed minus 2x cubed, so that's negative 8x cubed. Now I need the squares. So this guy, 10x squared plus 12x squared minus 8x squared. So that's 22 minus 8, which is 14. Yeah. Positive 14x squared. And then the x's. So this guy and this guy. Negative 20x plus 48x is positive 28x. And then just tag along that constant on the end of negative 80. So like, dang, Miss Coates, that's a lot of stuff. Yes, it is. That's why I said it in the last lesson. I try to break this up into a little bit more because this is a lot to do. A lot to do. And again, some of the questions, there's only 10 questions on the homework. Most of them, like I think there's 4 of them that are like, find the other zeros. And it's basically like finding the conjugates of things, or the opposite of a radical. And then maybe 2 here that you have to actually multiply out. So finding all the zeros of a polynomial function if we're given 1 0. Last time we did it, everything was a nice real number. There were no radicals. There were no fractions. There were no complex numbers, right? Well, today we have complex numbers. So if we do go through this, we want to find all complex conjugates, write the known zeros as factors. Oh, shoot. I might have put that. This is basically just kind of a rundown of what we just did. Simplify and FOIL. But other times when we need to actually find the zeros, so this would be finding the zeros, we might have to use long division or synthetic division. I didn't mean divisions. Factor or quadratic formula, kind of like we did last time. So really, we're going to be using synthetic division with complex conjugates, and we might have to use the quadratic formula today. So finding all zeros of the function given 1 0 here. So the 1 0 is 2. So if we recall, synthetic division, we put a 2 right here. And then we write out the coefficients of this here. All right, so I'm going to drop down this 1. I'm writing really big here, aren't I? 2, 1, negative 8, 30, negative 36. Okay, it's about the same. So 2 times 1 is 2. Then we add those. I get a negative 6. 2 times negative 6 is negative 12. 30 minus 12 is 18. And 18 times 2 is positive 36. So, of course, we knew that remainder there was going to be a 0. Right? So what would our leftover quadratic be? Because this was x to the 3rd. So this would become x squared minus 6x and then plus 18. And we need to either factor that, but last time we were able to factor it. This time we're probably going to have to use the quadratic formula. Okay? So, A, B, and C. So we know that x is equal to negative b plus or minus the square root b squared minus 4, and b squared should be in parentheses, AC all over 2a. So let's go about that. X is equal to negative b, so that's negative 6, so 6 plus or minus the square root of negative 6 in parentheses, squared minus 4 times A, which is 1, times C, which is 18, all over 2, times 1. So x is equal to, all that stuff in parentheses, we're going to put into our calculator. I'm sorry, all that stuff under the radical, put in your calculator. So parentheses -6, parentheses squared, minus 4 times, really don't have to do the 1, times 18. It's -36. So I have 6 plus or minus the square root of -36 all over 2. And what do we recall about a square root of a negative number? We pop an I out. But the square root of 36 is nice, is it not? So we have 6 plus or minus 6i all over 2. And those 6's can be divided by 2. So it's 3 plus I, 3 minus I. So our zeros are 2, 3 plus I, and 3 minus I. And I think there's only one question on the homework like that. All right, last but not least here. Find all zeros of the function f of x is equal to blah, 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 blah. If 1 0 is 2i. So last lesson I started off with synthetically dividing with an I. Remember I told you that you can use an I in your calculator. If it makes it simpler for you, you can still do that. So here, let's put a 2i inside of our box. And then I do my coefficients. 1, -4, 4, -16. Drop down this 1. 1 times 2i is 2i. I can't put that into my calculator because it's a real and imaginary number, right? So that really becomes -4 plus 2i. But now when I go ahead and multiply this -4 plus 2i times 2i, I can put that in my calculator. So we can do 2i, and the I is the second decimal button. So 2i parentheses -4 plus 2i. And that looks like it gets me a -4 minus 8i. Oh, well, those 4's cancel out, right? 4 plus a -4. So now I have -8i right here. And I'm going to have to multiply -8i times 2i. Which is 16. So that, in fact, got us a remainder of 0. Perfect. But now it's like, I can't make a quadratic out of that. But what I can do is synthetically divide still by this conjugate. So this 2i here is a 0. -2i must also be a 0. So I'm going to do, -2i. So I'm going to put -2i in my little boxy box. And then I'm just going to write down this stuff here. So I have 1, give yourself a little bit of space, plus 2i, and then minus 8i. Drop down the 1. 1 times -2i is -2i. So that cancels. So this is a -4. And then -4 times 2i is positive 8i. And that becomes a 0. So up here, I started with an x to the cubed. This became x squared. If I were to like decrease, my degree. So this is now x to the first. And look at that. That's x minus 4 is equal to 0. So then my other 0 would be positive 4. So my zeros are 4, 2i, negative 2i. And that is it. So it can get more complicated than this, but it's just way too much, especially when I'm not there. I'd have to say out of this whole lesson, the second two questions, so 2 and 3, were the tedious ones, but these are actually not so bad if you are using your synthetic division correctly and so on. But yes, this stuff gets tedious up here. And again, only 10 questions for homework tonight. I have noticed, and I'm saying this at the end of the lesson, some of you might have already turned it off, but I have noticed that some of you haven't even looked at the other video from last class. So that means you're not actually working in class on math. That kind of disappoints me. You wonder why I got you guys a sub. And I'm not saying that in a harsh way. It's just, if I was there, we would be doing this together. But because I'm not there and there's just a sub there, you might not be getting the work done in class. Just try to use your math class to do math, and so you don't have to do it outside of school. You know what I mean? So looking forward to seeing you all on Tuesday, and we'll continue learning about polynomials. We're going to actually learn not about polynomials. We're going to transition into rational functions. So that'll be actually some fun. All right, I'll see you on Tuesday. Have a good weekend.